The left-hand side of a formula governs a region within the cube that the formula is defined in or saved in. Going into more detail of that, a region, once again, is an intersection within the cube or the space of the cube. A cube, once again, or the space of a cube, is made up of the dimensions that exist within the cube. So to explain this better, let's do a new slice on future year model. The space of this cube is the intersection of actual versus budgets, accounts, regions, and months. A left-hand side can be defined as a space or a region within these four dimensions. Let's take an example of this. Let's select Model, Cube, Future Year Model, Formulas. What is a left-hand side? In this example here, we currently have two formulas defined, each with different left-hand sides. The first left-hand side is gross profit and Regions Canada. The second one is simply gross profit. A couple things to note about this. The first thing we're going to talk about is the all and syntax. There are three ways or three X and syntax that are supported by PowerOLAP. The first is an all and syntax. All and indicates that any formula, any value, any member within this cube that is either an aggregate or a detail that fits into gross profit and Regions Canada needs to be calculated when this formula is executed. The other options, and we'll see them by selecting these squiggly brackets, are aggregates and details. By selecting either aggregates and details or all, we can specify or define a different range for the left-hand side of our formula. In the cases we see here, regardless of whether the point that we're trying to calculate is an aggregate point or a detail point, all of them will be calculated by the formula. If we selected aggregates here when we wrote our formula or when we write our formula, only aggregate values that fall into that intersection will be calculated, and details as well. I'll select cancel. We'll go back to our slice and we'll look at our sample. We'll move accounts down to rows and months up to page. We can currently see that Canada, as a detail, the gross profit is calculated as 150. North America, which is an aggregate, is also calculated by subtracting sales and cost of sales from sales. What's happening is our formula is calculating at both an aggregate and a detail level because the syntax of our left-hand side says all and. Let's modify our syntax. Let's modify our formula. Hit Future Year Model, Formulas. For each of these, let's simply select aggregates. Select OK, and recalculate our sheet. As we can see, now only for values World and North America do we have a gross profit calculated. For Canada, since the formula states only aggregates and that intersection are calculated, we have 0. If we scroll over to the right, USA is 0. South America, because it's an aggregate, once again falls within the realm of the calculation. Let's go back into our formula again. Future Year Model, Formulas, and change this to details. Select OK. Recalculate our sheet. And at this point, we can see that they're both calculated. Why is this the case? The reason this is the case is because we have a details and formula. However, because we're calculating something at the detail level, those values are then aggregating into the values into their parents. So at this point, we have Canada being calculated at 150, USA being calculated at 280. Before, when we were calculating gross profit, we were calculating the 430 by subtracting the 1720, the 1240 from the 1720. Now, because we've changed our formula to be a details and, the 430 is actually calculated by summing the 150 and the 280. Going back into the formula, we can switch these formulas such that for Canada, we can do a details calculation. For gross profit for everything else, we can do an all-in calculation. Select OK. Select OK, hit recalc, and once again we receive the same values. The important thing to remember about this is that where you do the calculation might actually have an impact on the resultant value. In the sample we have, it doesn't matter whether you do the subtraction at the detail level and then sum to the total, or sum to the total and then do the subtraction. Besides the all, aggregate, and detail syntax, the left-hand side of a PowerOLAP formula can also define specific member ranges within the left-hand side of a PowerOLAP formula. In this example, I'm going to describe the selection or definition of the left-hand side of a formula within a PowerOLAP cube. I'm assuming at this point that people are familiar with what aggregates, details, and all does on the left-hand side. In this example, we're going to define the members that we want the left-hand side of a formula to represent. We'll start by selecting Model Cube, Future Year Model, Formulas. We currently have two formulas defined for the gross profit for Canada and for the general gross profit for the rest of the regions. In this example, we have details and all and. As we discussed earlier, those determine what members get calculated based on whether they're aggregates or details or all. In this example, gross profit and regions Canada also limit the left-hand side of the formula. This definition is the complete left-hand side determining what region of the cube will be calculated by the right-hand side of the formula. Details and gross profit and Canada will be equal to the right-hand side. In the second formula, all and gross profit will be governed by the right-hand side. As we discussed earlier, also the order of these formulas is important. What can exist on the left-hand side of a formula? There are three types of member ranges that you can have on the left-hand side of a formula. Each formula supports a group of dimensions, a group of members from each dimension in the cube. If a member is not defined for a particular dimension, it means that all members across that dimension are calculated within the formula or fit within the region. For example, in this instance, we specify that gross profit in Canada and details are on the left-hand side. We also have two other dimensions within the same cube, called actual versus budget and months. Given the left-hand side of this formula, the intersection or region will be gross profit for Canada for all detail members of actual versus budget and all detail members of months. Therefore, January, February, all the way through December will fit into this left-hand side region, as well as actual and budget from the actual and budget cube. As we see below, the only difference with this one is we do not specify a particular region. So the second formula will cover all gross profits across all actual and budget, including aggregates, since we're using the all left-hand side, all months, including aggregates, since we're not including months on the left-hand side, and all regions, except for the one that's already governed by the formula above. What else can be specified on the left-hand side of a formula? These examples show member lists, specific members within each dimension that you want on the left-hand side. You can select multiple members within an individual dimension. So if we wanted gross profit and some other member along the accounts dimension to be calculated, we could specify gross profit, comma, and the other member. Also, on the left-hand side, there are two other syntaxes that are acceptable syntax. First is the subset function. By using a subset function on the left-hand side of a formula, a user can manage the members that get calculated on the left-hand side of a formula or within the region of the formula without having to modify the formula every time new members are added. All the user has to do is simply maintain their subset. By maintaining their subset, the left-hand side of the formula will adjust based on the members within that subset. To build a left-hand side syntax for a subset function, we will simply select the left squiggly brackets, we will select a particular dimension that has a subset already defined in it, which I'll define as months. For this example, I'll just pick a member so that we can build a left-hand side to start with. Left-hand sides can be typed directly into the formula editor. If you want the assistance of the wizard, simply select the double squiggly brackets, and the wizard will give you a framework to start from. Now, within the months dimension, I know that I have a subset called quarter 1. I'm going to specify months dot subset single quote quarter 1, and I'm going to set that equal to a value. In this instance, I'm going to take my future year model. Actually, I'm going to pop. For simplicity's sake, I'm simply going to assign the result of quarter 1 to the value 10. I will check my syntax. No syntax errors. Hit OK. OK. Move months to my rows. Move accounts to the top. And as you can see, all values now within quarter 1, which is made up of January, February, and March, are now assigned the value 10. So, by writing a formula using a subset, you can see that the subset value itself is equal to the formula. Let me modify my subset. Select months, subsets, hit quarter 1, edit, and for sake of argument, I'm going to assume that April suddenly is part of quarter 1. Check OK, hit OK, OK again. As you can see, by simply maintaining and adding things to that subset, my formula updates based on the new members within that subset. April now has the value of 10. The other syntax is the child or children function. I'm going to select Model, Cube, Future Year Model, Formulas. And I'm going to create a formula that the left-hand side is a children function. So again, I'll start by typing all and squiggly brackets. And in this example, we need to specify what parent we want to use the children of. I'm going to select my regions dimension. The syntax is regions dot, then the name of the parent you'd like to use. I will select the square brackets simply to bring up I will click the squiggly brackets simply to bring up a reference to my members so I can see what members I have. I'm going to look at regions, and I'm going to see that I have a region called North America. I know that North America is an aggregate of Canada and USA. I'd like my formula to apply to Canada and to USA. I'll select cancel. So I do regions dot. I will put a single quote around North America to indicate that this is a member name or a literal within the formula language. And I'll append .children. I'm going to set this value equal to 20. Hit check syntax. There are no syntax errors. What this is going to do is it's simply going to look at the regions, go to North America, and tell it that the children of North America should be set to the value of 20. I hit OK. I hit OK. And we have regions here. I will recalculate. And as we can see, the children of North America are now set at 20. However, we can also see that some of them are 10. As we discussed earlier, the reason behind this is order of formulas. Because our formula that specified that January, February, March, and April, or quarter 1 was equal to 10, came before our formula that told us that the children of North America should be set to 20. Therefore, the 10s are showing here, and the 20s are showing here. An example, once again, of the order of precedence of your formulas.